We're in the process of restoring the 442, which is our Alco Alligator diesel locomotive. Good afternoon. I'm Robert Schoen, volunteer and president of the Austin Steam Train Association, and we're here today to get you up to speed with what we've done to the Alco so far, what we're currently doing, and what our future plans are. This locomotive was known as an alligator because of its rather long nose. About 25 years ago, we had to sideline our steam engine, the SP-786, due to some major structural problems that needed repair. When we came to the conclusion that repairs on 786 were going to be expensive, extensive, and very time-consuming, we turned our attention to purchase a diesel locomotive to continue running trains in the interim. After some searching, we purchased the 442 from Indiana High Rail and brought it down to Cedar Park. After a little bit of work, the 442 was ready to lead ASTA passenger trains and did well for a number of years. And even though we had some minor mechanical problems with the 442, we were always able to fix those during the weekdays when we weren't running trains. But being a one locomotive railroad still posed some problems. Given the short window of opportunity for repair on this locomotive, which was a Monday to Friday on any given week, we really never had an extensive amount of time to do major rebuilds or major work on the locomotive. So a lot of maintenance got deferred, and this eventually caught up with us. We began to have problems with the low voltage and high voltage wiring, oil leaks from the crankcase lube oil filtering system, and then the traction motor ground faults. We also developed a crack inside of our turbocharger during one particularly hard winter. It got to the point where we couldn't even get out of the yard without sustaining multiple ground faults, leading us to sideline the 442 for some long-awaited repairs in 2016. But in order to keep running trains, we had to lease a GP 40-3 locomotive, which we are still utilizing today, to pull our trains. And while the previous management wanted to scrap this locomotive, we thought this locomotive was rare enough and important enough to embark on a total rebuild of the locomotive, which we're going to talk about today. This locomotive was built by the American Locomotive Company for the Santa Fe Railroad in 1960. It was designated as a road switcher, which the term RSD-15 implies. Of the 74 RSD-15s manufactured, only 5 survive today, and of those 5, only 2 are operable, which includes the 442. So you can see the importance of returning this locomotive to operation. Despite the challenges that we are facing with the rebuild of this locomotive, primarily due to the scarcity of parts, we still feel that bringing this locomotive back to full operating condition is the right thing to do. The rebuild of 442 was imagined in 4 phases. The first phase was a limited refurbishment of the prime mover, including the injectors and the injector nozzles. The second phase is going to be a more extensive rebuild of the front and rear trucks. The third phase will be us tackling the high and low voltage electrical problems. And then the fourth phase will be a complete exterior and interior repainting of the locomotive. Phase 1 has already been completed. This involved a rebuild of the injectors, the injector nozzles, and resetting the valves throughout the prime mover. We started phase 2 of the restoration in February of 2020 with the removal and disassembly of the rear truck. When we brought the crane out to lift up the locomotive and to remove the rear truck from the locomotive, that same day we used that crane to help disassemble the rear truck, which involved lifting the frame off of the traction motors and also disassembling all the other parts that go along with the spring rigging and the equalizing arms. This allowed us to make a complete inspection of all the components of the rear truck. You may be asking yourself, what is an equalizer arm? Let's talk about how axles and wheel sets work in frames on locomotives. So we're looking at the front truck right now. We've got an axle here, we've got another axle here, and the third axle is behind because this is a 3-axle truck. In order for the engine, or any car for that matter, to get over a section of rail, which is not always typically level, the wheels and the axles have to go up and down to accommodate that unevenness and levelness. So this is the box right here for the axle, and this box has to ride up and down to accommodate that. This is the equalizer arm right here, which spans from one axle to the next, and it helps to equalize out some of that movement of the boxes that are in the frame itself. As you can imagine, over time, with these equalizing arms going up and down and rubbing against the adapter plates, which is right here, there's going to be a fair amount of loss on the load-bearing metal of each one of the equalizing arms. So these are the equalizing arm sets off of the rear truck. And the wear on the equalizing arms is typically down here on the bottom. And even though they've been repaired now, there were several of these arms that lost quite a bit of metal here, making them more or less unreliable. Our volunteers did full thickness weld repairs on the bottom by building a template which showed them exactly how much metal they needed to put back. Once welded, it was all ground smooth, inspected, and now painted. So let's consider the equalizing arms for the rear truck to be restored. Once again, this is a 3-axle truck. So you've got an equalizer that goes from axle 3 to 2, an equalizing arm that goes from 2 to 1, but they have to meet up somewhere here in the middle. And they meet up on this chunk of metal, which is what we call the equalizing arm adapter. Once again, you're going to see metal loss in the grooves of the equalizing adapter, which is similar to what we lost on the arms themselves. This is one of the equalizing adapters. We had to take these to a machine shop because the groove in here was so badly worn in places from the equalizing arms that they had to be machined down so that they would all be of a consistent thickness, so the journal boxes would ride at a consistent height with the equalizing arms. This is the repaired rear truck of 442. These trucks are casted pieces, so you want to minimize the wear on the friction surfaces. The journal box rides in this gap here. It's called the jaw. And either side of the jaws have pedestal liners welded on it to minimize the wear to the casted portion of the truck. Here's one of the old pedestal liners, and it was so badly worn and rusted and it lost a lot of its thickness that we had to order new pedestal liners. These are the new pedestal liners on the jaws themselves. The problem was they just did not fit exactly the way we wanted them to fit. So we had to take and cut one part of the pedestal liner off, mount the rest of it to the jaw, and then weld this to make it a continuous pedestal liner all the way around the jaw. Now the dimensions between the pedestal liners are exactly the same, top to bottom, center to center, for all 6 of the jaws. Underneath this very expensive and custom fabricated cover is the center bowl. The center bowl is what the locomotive frame articulates with and rests on. It had a fair number of defects, including cracks in the liners around the center bowl. All of that has been welded, but we're keeping this under cover to protect it. These are the loading posts on the frame. They also bear the weight of the locomotive, but they do so more in a lateral fashion away from the center of the frame itself. They also help to control some of the rock and the sway of the locomotive, minimizing that as the locomotive goes over the track. The loading post felt brackets had been smashed during an old traction motor lift, and new brackets could not be located, so the old brackets had to be refurbished. The metal was heated and straightened, and new welds were made to reassemble the brackets. New felt will be applied before the truck is moved back underneath the locomotive. While we were working on the pedestal liners, we took the opportunity to wire brush down the entire frame to bare metal. What cracks we could identify were repaired. The frame was primed and it was painted in a high gloss black, and this is just the first coat. It'll be painted again. We also had the opportunity to get under here and work on some of the frozen brake rigging parts and loosen that up as well. So this is a traction motor from the rear truck of 442. What a traction motor does is it is essentially an electric motor that turns a pinion, that turns a wheel. Your electricity, which is generated by the main generator on the locomotive, comes in through these cables. Inside of this box right here is the actual electric motor that turns. At the end of the motor is a small pinion gear, which interdigitates with the large gear inside of this wheel right here. So the electricity makes the motor go, the gears make the wheels go round and round. This is traction motor number 5. It had a bad traction motor and that had to be replaced, which was done by our mechanics. Traction motors 4 and 6 were cleaned up inside and out, including an emery cloth to clean the commutators by hand in order to remove tarnish from the copper. The inspection covers were cleaned and repaired as needed, and new seals were reapplied to all the inspection covers. Dust covers, gearboxes, and traction motor support bearings were resealed with a high temperature, high oil resistant type of caulking. This is one of the journal boxes on the rear truck that's undergoing repair. The journal box rides over here on the roller bearing of the axle. The wear plates on the boxes were badly worn. This is a wear plate that's badly worn, even worse after we had to cut it off, but that wear plate would sit here on the side of the box. There was a lot of rust between the box and the wear plates. That was making the plates bulge out. That was adding to the inflexibility of the boxes being able to move up and down in the jaws. Once the wear plates were off, then we had to address all the metal damage on the box itself. Right now, all of this has been cleaned. The defects are going to be welded up, and it's going to be ground down to a smooth metal. After that's done, new wear plate material has been ordered, and this is a much tougher steel that can take the wear. So this is one of our sample wear plates here, and as you can see, all of this has been repaired, so you have very few defects in it to collect water and create rust. So the wear plate then has to be welded to the box. So this is a finished journal box here. This is the new wear plate. It's been welded specifically in a variety of places. There's really no gap between the wear plate and the metal of the box itself, so this should last us for a nice long time. As you can imagine, it took a fair amount of work to get the wear plates off. It took a lot of work to prepare the metal, and it took a lot of work also to get it welded back up again. And a number of our volunteers who are fairly good at this helped out in getting the metal prepared, getting the box prepared so that the plate can be welded on and we can move on to the next step. Once the welding is complete, the bearing boxes will be reunited with their bearings on the rear truck. The rear truck will then be reassembled and reinstalled underneath the locomotive. We hope to have this finished within the next couple of months. This is one of the battery boxes of the 442. The 442 uses lead acid batteries, and that lead acid, especially the acid, tends to spill over and it tends to rot the metal. This whole back wall here was just about eaten away because of the acid that was coming off the batteries. So all of that had to be cut out, new metal had to be put in, had to be re-welded, and we had to do that on both sides of the locomotive. Once we get these boxes wrapped up, we need to fabricate new battery box doors, and this time we're going to include vents with them to help ventilate this compartment and minimize the corrosion. The fan room, which had accumulated much grease, grit, and grime, was thoroughly cleaned. All of the grease, the grime, the sand that was in here has been thoroughly cleaned. Some of the surfaces have been preliminarily repainted. This is the oil filter tank that had the bad leak, which caused a lot of the contamination of the fan room. That has been resealed and reprimed. Now let's go look and see what's going on with the cab of the locomotive. As you can see, the cab was completely disassembled on the interior. There were a lot of defects in the metal walls, holes, bolt holes, etc. that needed to be sealed up. There was a large defect up here at where the roof meets the back of the electrical cabinet, which had to be welded up because that was an ingress spot for water. After that was done, all the metal was stripped, primed, and we're currently repainting it in a more authentic color that the Santa Fe would have had it in when it was in service. The nose of this locomotive was really a wreck. Let's step inside. Most, if not all, of the interior paint was starting to peel off the inside of the nose. There was a lot of rust in here. So our volunteers came in, stripped out all the paint, sanded down all the surfaces, repaired all the rust defects, and painted this in a primer gray. We'll go ahead and paint this with the interior color that you saw in the cab. Once we get the rear truck underneath the locomotive, we're going to need to start thinking about working on the front truck. No doubt it's going to need the same amount of work. It's probably going to need a traction motor. But from the lessons that we learned from the rear truck, perhaps we can do this a little bit quicker and save us some money in the process. We would also like to give a very big thank you to the John H. Emery Rail Heritage Trust for their generous grants to fund portions of this project. While we're working on the front truck, we will also start on phase 3, which is looking at the wiring both on the high voltage and the low voltage side of this locomotive. Clearly there's some wiring that needs to be replaced and upgraded, and this will give us a good opportunity to do that. After we get that done, we're going to do a thorough inspection of the prime mover to make sure it is completely up to spec so that when we start to run it, it runs seamlessly for us for years to come. And when all the work is done, we're going to repaint the locomotive in a modified Black Widow paint scheme as a tribute to the Southern Pacific, whose line we run on. As always, we appreciate your support and we appreciate your donations. If you'd like to donate to this project, please go to our website, austinsteamtrain.org. On the next video on this project, we will cover the reassembly and reinstallation of the rear truck under the locomotive. Thanks for watching.